Hello everyone. Welcome to Ganit. My name is Utsav. We're going to talk about some basic principles of exponents today. We also call it indices, whatever you call it. So I will teach you the same rules that you've been learning for a very long time. We call it laws of exponents, the same set of rules. But what I'll try to do is I'll also explain you with a few examples. I will try and focus more on the laws that are going to help you directly in a question. So without further delay, let's just start. So we're going to talk about exponents. So the laws basically. First law is a to the power 0 is 1. So anything raised to the power 0 is always 1, be it a fraction, be it a normal number, negative number, positive number, doesn't matter. Anything to the power 0 is 1. Second law, in that sequence of you know order. So we have a to the power m times a to the power n can be written as a to the power m plus n. Now remember, this law has to be applicable in both directions. So example, suppose I give you 5 to the power x times 5 to the power 2. You will very easily say it is 5 to the power x plus 2. But the questions will ask you 5 to the power x plus 2. So you should know that if 5 to the power x plus 2 is given in a question, I can also write it as 5 to the power x times 5 to the power 2. So the laws, be it exponents or any other law, it always works in both the directions. It's not a one-way traffic. You have to remember and you have to be flexible enough to know that 5 to the power x plus 2 can be written as 5 to the power x times 5 to the power 2. Let's move to the third identity. Something very similar. A to the power m divided by a to the power n again can be written as a to the power m minus n. Same example applies to this one as well, except here there is a minus sign. So something similar will happen in an actual question also. So you might have 5 to the power x divided by 5 to the power 2. So you will write it as 5 to the power x minus 2. So for instance, you have, let's take another number, 3 to the power x by 3 to the power 7. So you can write it as 3 to the power x minus 7. There is a reason why I'm drawing these double-sided arrows. It indicates that the rule does not apply only from left to right. It also works equally well moving from right to left. All right. Fourth one, a to the power m whole to the power n can be written as a to the power mn. All right. So very important that if you see two different exponents involved, one is inside a bracket, another one is on top, remember you have to multiply them. Do not add them, do not subtract them, multiply. But there is no rule for division of exponents. So if you see, the second rule is talking about addition, third is subtraction, fourth is multiplication, but there is no rule for division of exponents. So be careful with that. Do not apply division of exponents anywhere. Fifth one, very important, a to the power negative m can be written as 1 by a to the power m. So suppose, example for this is very, very important. So suppose you have 3 to the power 5, 3 by 5 to the power minus 2, beg your pardon. So 3 by 5 to the power minus 2. Now, whenever you see a question with a negative exponent, I'm going to create a whole series of lectures which will cover different types of questions as well. So we'll see these kind of questions appearing there. What you need to understand is that if I have a base and it is raised to the power a negative number, my first job is to make the number positive. Which number positive? Not the base. The exponent is positive. How do we do that? We flip the base. It becomes 5 by 3 and to the power 2. So exponent becomes positive, the base flips. Remember that. The sixth law, again, very crucial. A to the power 1 over m can be written as mth root of a. So mth root of a, for example, I will explain you with an example. So if I have, let's just say, cube root of 64, I can write it as 64 to the power 1 by 3. But that's a very classic example, by the way. But I don't think this example alone will suffice. I want to talk about a couple of more examples here. So suppose I am dealing with, let's just say 81 to the power 3 by 2, right? Now, it's actually a mix of law number 6 and law number 4. How? So 3 by 2 as a fraction can be written as 3 times 1 by 2. And multiplication of exponents, if you notice, is applicable on rule number 4. So a to the power m whole to the power n can be written as a to the power m plus, sorry, mn, right? So 3 into 1 by 2, what I can do is I can distribute it as 81 to the power 3 whole to the power 1 by 2, or 81 to the power 1 by 2 whole to the power 3. Now you have to ask yourself, if you look at the law number 6, if I wanted 81 to the power 1 by 2, would that help me better? Or if I had 81 to the power 3 and then to the power 1 by 2, that's going to help me better? I don't think so. Because 81 to the power 1 by 2 also means that you're supposed to find the square root of 81. And square root of 81 is pretty much possible. It's a proper perfect number, right? It's 9. But if you cube 81 and then try to find the square root, it's just the sequence, You are cubing first and then going to the square root, or you are square rooting first and then going for the cube. I would suggest the second option, because the square root is a clear case and it's a very, very easy thing to know. So 81 to the power 1 by 2 is 9, and 9 to the power 3. Okay, so this is the core of laws of exponents. We will get to learn about these laws predominantly with the help of so many questions out there, right? There is no point in learning laws too many times. Just know the fundamentals and then start practicing your laws with as many questions as possible. All right. In the next slide, we are going to talk about the various type of questions available in the syllabus for grade 9th as well as 10th exponents. All right. For now, take care. Bye bye.